Hello, my dear students in basic meteorology. How are you this morning? How are you today? I am your teacher in Physics 7, Basic Astronomy. My name is Professor Ablong. Our course, Basic Meteorology, is a 5-unit course. We have here 7 contact hours in a face-to-face class. We meet twice a week. The schedule here is Tuesday and Friday. So Tuesday 8:30 to 12 and Friday 8:30 to 12. Face-to-face, we will always see each other during our scheduled class meeting. But because this is an online distance learning and Silliman University considers some of the circumstances like internet speed, right? And other circumstances related to online distance learning. So therefore, in our course, just like other courses of Silliman University being offered, we will have both online activities and offline activities. Okay? And during the online activities, we will be having a real-time online video discussion interaction. And during that period of real-time online video interaction, we will be having some discussions. Then you can interact with me. You can ask questions. Any question about our lesson. Okay. So, the course description of basic astronomy is that there is the premise in the description that astronomy is the oldest of all sciences on planet Earth. It's the oldest. This course studies the universe starting from our own planet Earth to beyond our planet Earth. How and when the existence of the universe started, and how and when the Earth originated will be dealt with in this course. The physical characteristics and behaviors of the planets and other members of the solar system and beyond are scrutinized using the laws of physics. As part of the synchronous activities, the teacher of this course will have a scheduled online real-time video discussion and interactions with the students. We have some course outcomes, meaning at the end of the course or after completing the course, the students are expected to 1, 2, 3. We have 3. At least 3. The students are expected at the end of the course to illustrate and evaluate the various theories about the birth of the universe and apply the current scientific findings on the fate of its existence. Number 2, the students at the end of the course are expected to create his own geographical, his or her own geographical location, a night sky map of all visible, objects on a monthly basis. Also, at the end of the course, the students in basic astronomy are expected to apply the individual physical characteristics and behaviors of the night sky objects in identifying them. Okay? And also, I would like to remind you of our class policies. Okay? I have here my laptop here. I'm looking at our policies. Okay? And what are these policies? Each student is required to participate in every scheduled online video discussion interaction with the teacher. Attendance will be checked here. Okay, so never be absent because our real-time online video discussion will be scheduled and you are informed, in other words, in advance prior to the real-time online video discussion using the big blue button of our Sol. Our Sol is complete already. No need to go to Lark, to Zoom, no need. Because we have everything in Sol. Okay? Okay. Number 2, class policy. Midterm and final exams are given at real time using the big blue button. So, midterm, final exam, and even long exams, they are all scheduled. You will be informed. We will have it at real time. So, face-to-face, virtual, face-to-face. Number 3, class policy. All assignments and other tasks assigned to you, students, to you, should be submitted on or before the given deadline. So there is a deadline in Sol. Okay? And when that deadline has lapsed and there is the cut-off deadline, meaning submission will not be accepted anymore, you cannot submit that anymore. So you have to message me using the Sol. Sir, I would like to submit my assignment, my activities, sir. So you will be taking a lot of time because your class, this class is not the only class I am attending to. And teachers in the online distance learning very, very busy because you are making reading materials for you. In fact, I have already sent to you at least 3 books, electronic books, for you to read. And these electronic books you have to read because I am making a summary of the 3 books I was sending you. Okay? So, we teachers in Selma University are very, very busy because we would like you to provide the same quality education. So, we are very, very busy. So, you must be also busy with your own duties and responsibilities as students. Okay? Now, the works should be done, assigned works, assignments, other tasks, should be done directly, personally, and exclusively by you, students. So, you have to do it yourself. Do not let others do the work for you. Okay? The authenticity and compliance of this requirement should be shown with digital pictures submitted together with the assignment or assigned work. Meaning to say, because I will not be with you during the time when you do the assignment, when you do conduct the activities, I will not be with you besides you. I need a proof that you did it. That work, you did it. Directly, personally, and exclusively by you. So there's a picture you're doing your work. So you ask your parent, guardian, or whoever with you at home to have some pictures, digital pictures, if not a video clip not more than 5 minutes during the performance of your work. Okay? Okay. Number 4, class policy. Failure to submit the assignment or any assigned work on time must be duly justified by you. My dear students, you justify your failure of not submitting the assignment or other tasks assigned on time or within the deadline. Okay? You justify that you are given 2 days after the deadline of submission has lapsed. Must be duly satisfied by you within 2 days after the deadline of submission has lapsed. The justification includes the handwritten statements and signature of your parent or guardian certifying the truthfulness of such justification, my dear students. Okay? Anyone at home who knows about your predicament, about your circumstances, why you were unable to submit your work on time, that anybody or somebody at home with you will have a handwritten statements. Picture the handwritten statements on bond paper or pad paper, okay? Submit that together with your picture of the assignment, because your assignment, by the way, is also handwritten. You are going to answer all the questions handwritten. Then picture, submit together with that justification. And by the way, all the assignments, once you are assigned to answer about our lesson, you are going to do that using your handwriting, your own handwriting, not anybody's handwriting. Okay? I hope you understand that. If you have some concerns, you have some clarifications, you can message me using our soul. Okay? Now we'll proceed. We will proceed to our lesson about astronomy. Okay. I have here the laptop. I have here the laptop. That's why I'm facing, so that I will be guided. Okay. So that I will be guided. Now, this course, astronomy, is the study of the objects that lie beyond our planet Earth. All those objects in the sky. As far as our eyes can see. And as far as the instruments, man-made instruments can see and observe. We will be studying those objects. And the study we will start from our planet Earth. We study all those objects lie beyond our planet Earth and the processes by which these objects interact with one another. We will see, though that it is not, or we will be having that, though that is much more than that. Okay? We'll be doing much more than what our course is telling us, because if we have more time, then we go further. Okay. Astronomy is also the attempt of humanity to organize what we learn into a clear history of the universe, from the instant of the birth of the universe in the Big Bang to the present moment and in the future to come. Throughout this course, we emphasize that science is a progress report. That one that changes constantly as new techniques and instruments allow us to probe the universe widely, more widely, and more deeply. In considering the history of the universe, we will see again, because we have to go back, okay? What was done by the early people at the time? What did they observe? What did they do? In considering the history of the universe, we will see again and again that the cosmos evolves. It changes in profound ways over long periods of time. For example, the universe made the carbon. The universe made the carbon, the calcium, and the oxygen necessary to construct something as interesting, as complicated as you and me. Today, many billions of years later, the universe has evolved into a more hospitable place for life. Tracing the evolutionary processes that continue to shape the universe is one of the most interesting, if not the most satisfying parts of modern astronomy. The ultimate judge of science, or the ultimate judge in science, is always what nature itself reveals, based on observations, based on experiments, based on models, and of course, testings. Science is not merely a body of knowledge, but a method by which we attempt to understand nature and the nature of nature and how it behaves. This method begins with many observations, so many observations over a period of time, and what is needed is your patience and diligence. Okay? If you want to become an astrophysicist, an astronomer, you have to be patient, because you have to wait the sky to be cloudless sky at night, and you do the good observation only on cloudless, moonless night without the moon, so that the brightness of other objects in the sky will have no competitor, which is the moon's brightness. So, from time to time, this is being done. Okay? The method begins with many observations over a period of time. The method of observation. Experiments from time to time. Constructing models. As a concrete astronomical example, ancient astronomers constructed a model, partly from observations and partly from philosophical beliefs. Remember, philosophy here is also very active in the role of knowing what is there, why it happens like that, how it happens like that, why. So a lot of philosophical questions come into play. Okay? That even in the early days, it was taught, and not only philosophy comes in, but also our belief in God, the religious aspect. In the beginning, the earth was thought to be the center of the universe, and everything moved around the earth in a circular orbit. Everything. So, including the sun, the moon, planets, everything, the sky, move around the earth. The sun, for instance, early in the morning is over there. Then later in the morning, over there, high noon. And there, every day you observe the sun moving around us, moving around the earth. So there was that model that the earth is the center of everything around it. At first, our available observations in the early days, the observations in the early days of the sun, the moon, and planets fit into this model. Fit into this model. We call this model the geocentric model. However, years after, and after further observations, after further experiments, and making some models, we now know that the earth is not the center of the universe, not even the center of the solar system. As the centuries passed and improved, instruments were able to develop for tracking objects in the sky. The old model, even if there are a lot of followers there, could no longer explain all the current observed facts. And so the old model was rejected. And comes another model. And so, that is how we are going to look at astronomy. When models are proposed, new ideas will come in. And these ideas we call hypothesis. We may think there can be no new hypothesis in science, such as astronomy, that everything has already been learned. Nothing could be farther from the truth. Throughout this course, you will find discussions of recent and occasionally still controversial hypotheses in astronomy. For example, the significance that the huge chunks of rock and ice that hit the earth have for life on earth itself is still debated. Even the looking of light beyond the planet earth, because there is this one question that prevails and keeps on motivating man. This question is, are we alone in the universe? So man is keeping his or her eyes forward, looking for the answer to that question, are we alone in the universe? Is life only exclusive to the earth? Okay? So, there are a lot of philosophical questions also having this course coming into play. The last point is crucial. A hypothesis must be a proposed explanation that can be tested. The most straightforward approach of such testing in science is to perform an experiment. If you want to test the hypothesis, perform the experiment. Perform the experiment. So that the hypothesis could be what we call accepted, if not rejected. If the experiment is conducted properly, the result of this experiment either will agree with the predictions of the hypothesis or they will contradict. The results will contradict. It's either or. Agree with the predictions, the results of the experiments, either or agree with the predictions or contradict the prediction of the hypothesis. If the experimental result is truly inconsistent with the hypothesis, the scientists must discard the hypothesis and try to develop an alternative. If the experimental results agree with predictions, this does not necessarily prove that the hypothesis is absolutely correct. Perhaps later experiments will contradict crucial parts, substantial parts of the hypothesis. But the more experiments that agree with the hypothesis, the more and more experiments that will agree to the hypothesis, the more likely we are to accept the hypothesis as a useful description of nature, as the prevailing fact of nature. One way to, or when you read about experiments, I'm looking at my guide. You probably have a mental picture of a scientist in a laboratory. You read the experiment of professor or doctor or the expert doing the experiment. You have that mental picture. The one doing this experiment is inside the laboratory, doing the experiment, taking careful measurements, taking careful testings. This is certainly the case of a biologist or chemist or physicist. But what can astronomers do when, in my case, I am an astronomer. What can I do when my laboratory is the universe, the entire universe? That's my laboratory. What can I do? It is impossible to put group of stars into a test tube. I will get this asteroid, put that inside the laboratory. I'm going to get one asteroid, put that, I will bring that to the laboratory and do the experiment. Or get one comet there, I will get one comet and put that in the laboratory and conduct the experiment. Astronomers cannot do that. Unlike the biologists or chemists, they can do their experiment inside the laboratory or probably out there in the field, but they can touch the samples, they can get the materials. But how about the astronomers? How will I get the soil from Mars? I will go to Mars. I will get some soil. As a result, my dear students, astronomy is sometimes called an observational science. Astronomy is sometimes called, or most of the time called, an observational science. Observation. We often make our test. I mean, there are astronomers by observing many samples of the kind of object we want to study. So several samples similar to that object there, unreachable object. Good, because of space travel technology, we were able to get some samples from the moon. But samples on Mars cannot be taken for now. We are just relying on that walking laboratory there, robotics. We are relying to the samples. And like for instance, the Mars rover Opportunity, and the one that has been sending man or NASA so many precious samples, digital only, can be seen by digital samples. Of course, a lot of testings, they're using their instruments there. That robotic there, the Mars rover Curiosity, always busy getting some samples. But to get actual, so that scientists could touch, new instrument and technology can let us look at astronomical objects from new perspectives in greater detail. And that is being done now here with respect to the Mars rover Curiosity. There is that another one, but the Mars rover Curiosity is the one that has the most precious sample so far taken for man's knowledge. Our hypotheses then about astronomy are then judged in the light of new information, and these hypotheses, they pass or fail in the same way we would evaluate result of a laboratory experiment. Much of astronomy is also a historical science, so we consider those studies done by Galileo, by Tycho Brahe, Johannes Kepler, so many of them, and so on and so forth. So, over centuries, scientists, astronomers have extracted various scientific laws from countless observations, countless hypotheses, and experiments. These scientific laws are, in a sense, the rules of the game that nature plays. One remarkable discovery about nature, one that underlies everything you will read in this, you will know in this course, is that the same laws apply everywhere in the universe. Laws of motion, applicable on Earth, applicable on Mars, applicable over there at very, very far distant objects. Note that without the existence of these universal laws, like universal law of gravitation, is a universal law. This law of physics is applicable anywhere in the universe. Okay? Anywhere in the universe. Without the existence of these laws, we could not make much headway in astronomy. We cannot. So we need to have the application of universal laws. Laws that are applicable anywhere. So, this is what we are going to expect. Now, one important problem in describing scientific models has to do with the limitations of language. When we try to describe complex phenomena in everyday terms, the words themselves may not be adequate to do the job. For example, you may have heard the structure of the atom likened to a miniature solar system. Right? Structure of the atom, you have the nucleus, the center of the atom, the nucleus, very massive part of the atom located at the center, and this is being likened to the solar system where at the center is the sun. And all the planets are the electrons. Okay? It's something like that. Okay? While some aspects of modern model of the atom do remind us to planetary orbits, some aspects only, many other of its aspects, so many of them, are fundamentally different. So, the comparison that the solar system is similar to the structure of the atom, it may not actually work as a whole. This problem is the reason scientists often prepare to describe their models using equations rather than words. In astrophysics, we use equations rather than words. In this course, okay, we use, however, mainly words to discuss what scientists have learned. Because I will try to present this course in a practical and non-mathematical manner. So, but of course, we cannot avoid numbers. Okay? We have a lot of numbers in astronomy because in astronomy, we deal about numbers. In astronomy, we deal with distances on a scale you may never have thought about before, with numbers larger than any you may have encountered in your life. We will be dealing with astronomical numbers. We use scientific notation. We use astronomical unit. We use also the most common and, let's say, very useful is in terms of light year. A common unit astronomers use to describe distances in the universe is light year. Light year is not a unit of time. It is the distance light travels in 1 year or during 1 year. So, light year. Using the speed of light is very useful to the astronomers. Because the speed of light is the fastest speed in the universe. There is nothing can surpass the speed of light. Otherwise, if there is something that will surpass the speed of light, we have to demolish all the laws of relativistic physics. We have to abolish. So far, it remains as a universal law that the speed of light is the limit of all speeds in the universe. So, we see light year, we have to use the speed of light. What is the speed of light? My dear students, the speed of light is 300,000 kilometers per second. What is 300,000 kilometers per second? Very difficult to imagine 300,000 kilometers per second. What is it? Well, to imagine that, to simplify that, we imagine an airplane that can travel equal to the speed of light. If that airplane can travel equal to the speed of light, that airplane can revolve around the earth, turn around the earth, circle around the earth in 1 second, at least 7 times. 1 second, 7 times. That is how fast the speed of light. To go to the moon, using a spaceship, a space vehicle that can travel equal to the speed of light, it will take only about 1.25 seconds to reach the surface of the moon. 1.25 seconds. Speed of light. 300,000 kilometers per second. And that speed remains as such, the speed of light. There is only one value for the speed of light. Traveling in one medium. Of course, in a different medium like water, there is now what we call the laws of refraction. There is the bending of light because light travels slower in water than in air. So we consider the index of refraction. But in an empty space. Like over there, an empty space. Over there, in the outer space, an empty space. The speed of light is 300,000 kilometers per second. Light coming from the sun, traveling with that speed toward the earth, will reach the earth 8.3 minutes. So the distance traveled there, we call that light minute, 8.3 light minutes. 8.3 light minutes. That means light travels in 8.3 minutes. Means 1 light year, that means light travels in 1 year. In the case of the moon, light travels in a matter of 1.25 seconds. So we have 1.25 light seconds. That means light travels in 1.25 seconds. 1 light year means light travels in 1 year. In the case of light coming from the sun, 8.3 light minutes. That means light travels in 8.3 minutes to reach the surface of the earth. We see the sun? We see the sun there? Because there is light coming from the sun. And once we see the sun, that sun is not the present sun. Huh? That sun is not the present sun. It is the sun 8.3 minutes ago. My dear students, when you look at the sky, you are not looking at the present object. You are not looking at the present objects in the sky. You are looking at the objects in the past, not the present. The next nearest star, because the first nearest star is the sun from us. The sun is a star. The second nearest star, the Alpha Centauri, 4.3 light years. That's the distance. 4.3 light years. Meaning to say, light coming from Alpha Centauri travels 4.3 years to reach our planet Earth. The distance there, 4.3 light years, means the distance traveled by light in 4.3 years. So when you look at Alpha Centauri, you do not see the present Alpha Centauri star. You see the Alpha Centauri star 4.3 years ago. So we have this light very important as our unit of measurement in terms of distance, light years. We will be discussing more and more about this. Meanwhile, I am giving you the first assignment. You look at the soul because the assignment will be about the solar system. Okay? And there will be a deadline. You constantly visit our soul. Bye.